Hello, my name is Konrad Kokosa and today I would like to show you another example from pull request from the Microsoft Diagnostic Library that I showed you recently. We were analyzing their pull request that was all about reducing memory allocations with the help of span, stack alloc and array pull. And recently, in the previous example, we started to describe the misaligned read and methods that were just to deserialize bytes from a memory into a values like unsigned integers or unsigned longs. So we said that instead of using an array of bytes which requires heap allocation, this PR is using stack alloc to represent a very small buffer that will be used for as a buffer for the serialization. So the reader is reading the data from the given address to this particular stack allocated buffer. This is one important optimization that allows us to get rid of arrays. But another very interesting thing here is how this byte array is being interpreted as, for example, unsigned int. In this particular pull request that I'm describing here, we are doing something with the help of Unsafe class that was able to reinterpret the value under the given address as a value of a given type. But to do that, we needed to take an address of this particular stack allocated buffer, because this is how this API is working. So we needed to fix this buffer because to take an address of anything in .NET, we need to fix its address. This is how things are working. This is because when we are taking an address, we need to make sure that no one will change this address. We need to make sure that this object won't be moved. But in this particular example, it is seems to be quite unnecessary, because we know that we just stack allocated a buffer. So this is a buffer on the stack, and addresses on the stack cannot be changed. There is no such thing like moving stack frames. So when we have a span representing a buffer on the stack, its address simply won't be changed. And this fixed keyword here and the fact that we in fact need to pin this address for a moment is overhead, which is unnecessary. And this has been fixed in the recent version, so I would like to show you the current version of this code in the current master branch in the ClrMD library. So the first lines are the same. We are just stack allocating small buffer. We are using data reader to read this into this buffer, but then some extension methods on the span has been created to reinterpret the data pointed by the span as a given type. So for example, we have this unsigned int conversion, and this has been added, as I said, to span. So this represents a few bytes in memory pointed by the span, and we want to reinterpret it as a unsigned int. Those lines obviously are not needed for our considerations because it is only for debugging, but here we see how this conversion simply happens. We are using two quite magic low-level APIs here. MemoryMarshal class and its getReference method allows us to get an address pointed by a span. So this is simply saying I want to have an address which is represented by this span at the beginning of the span. So this is simply an address on the stack. This is passed by reference because in fact we are using here manage pointer, which is pointing to the stack, and then we know that this address is representing a value of a given type, and we hope that it represents it as a given type. So instead of treating it as a byte, so instead of treating it as a series of bytes, we are just casting it in terms of something like in C++, we are just casting it to unsigned int. And because we are casting it, in fact, it means that all those bytes will be reinterpreted as unsigned int, and it will require as many bytes as the unsigned int requires. So this is kind of a casting instead of pinning and reinterpretation. We are just casting a given address to the value under the given address to a specific value which we expect, which is very interesting. And that's all. Thank you for today.